All right, Whoop, there it is. I love it. That's Mr. Sullivan and his Whoop, there it is t-shirt. As you can tell, I think Mr. Kelly's a little bit better at Photoshop than I am, but I'm getting there. All right, let's get rid of that. Whoop, there it is. Why are we doing that? It's the last section of the chapter and the last one of the semester. And hopefully you can go through this one quickly, wrap it up, take the exam, and you'll be good to go. So what are we talking about? We're doing the side splitter theorem. Let's check out perspective drawing. This is called one-point perspective. If it's based off of 1 point up here, so like up here in the corner, and then if you draw lines out of it, you can make things look 3D or like they're coming out of the paper. Like this is a road, here are the lights. What's cool about this is these are all parallel lines right here. So when we do this, we're going to put these parallel lines. What's going to happen? Well, it's going to be cool. If I want to find X, to make sure I've drawn. So what are we doing? So this perspective drawing, what's cool about this is you can say, oh yeah, this segment is proportional to this segment, just like this segment is proportional to this segment. So you can say 0.5 is to 0.42, just as 0.57 is to X. And then you can find X and you're good to go. So perspective drawing is pretty cool. The ending clip on this is pretty neat with perspective drawing. Let's go ahead and formalize this. So that was pretty quick, really summary, but this is called the side splitter theorem, and we're going to build up to what we were just looking at there before. This says if we got this picture triangle here, this is mathy. If a line is parallel to one side of a triangle, so if this is parallel to this, check, and that's given. If what and intersects the other two sides, then what? Then the sides are divided. Ooh, my handwriting is rough. Proportionally. So it divides them proportionally. That's the whole idea here. Then they're divided proportionally. Let me rewrite that. That looks a little rough there for divided, but hopefully you're writing and copying that down. Yours looks better than mine. Excellent. So what does that mean? So what's cool about this is let's go ahead and write down what this means. Here's my picture. It means that what? This side is proportional to this side. So MH is to HY as what? What has to be true? If I go on the flip side, AT is to TY. AT is to TY. So they're proportional. And then we can use that to solve lots of stuff. So that's the side splitter theorem. Sometimes you think, guys, do you guys just make this stuff up? Mr. Kelly, Mr. Sullivan, they just making these things up. Let's prove it to make sure that's true. So if these are in fact parallel, we don't have to do a formal proof, but let's take a look at it, make sure that we're not just making stuff up here. What do we notice about 1 and 2? Look at angle 1. It is a corresponding angle to angle 2. Remember the parallel lines cut by a transversal? This angle is this angle. So they're the same. What do you know about 3 and 4? Oh, check that out. They're the same. So what has to be true about these triangles? Well, they are similar. Why? By angle-angle similarity. I know if those angles, so if we're looking at this little triangle up here, this side of the little triangle is to this side of the big triangle. Then what happens over here? This side of the little triangle is to the big side of that. And the bottom one, oh, I better use green. The bottom one of this is to the bottom one of this. Pretty cool. So yes, it is true. We can go to more formal proof, but it does work. We're not just making this stuff up. Let's do some problems with it real quick. Make sure we are okay with it. So how we set this up? Well, I'm going to say 3 is to 1, and there's a couple ways to do it, but this is the way I'm going to do it. Try to keep it easy. 3 is to 1 as what? Then I got to match them up. 6 is to question mark, or I'll call it X. And then we got a proportion. This chapter is all about proportion, so cross multiply and solve. So 3 times X is 3X. 1 times 6 is 6. X has got to be 2. Done and done. And maybe you knew that. It makes sense. 6 is to 2 is 3 is to 1. Cool. Awesome. Moving on. Let's try the next one. Same thing here. I can say 6 is to 15 as what? X plus 3 is to 25. So 6 is to 15 as X plus 3 is to 25. Awesome. Can we solve this? Sure. We're going to cross multiply, so we can say 6 times 25 gives me what? 150. Then I'm going to say 15 times X plus 3. And then I'm going to distribute this and make sure I'm good. So really 150 equals 15X plus 45. Subtract 45 from both sides and you get 105. Does 15 go in there evenly? 15 goes in there, oh my gosh, 7 times? Is that right? 70, yeah, 7 times. So X is 7. Fantastic. Moving on. How about this last one here? I'm going to say what? 4 is to 24. No, careful. That's the whole side. So this side that we're looking at is 20. So you can say 4 is to 20 as, oh, I don't know this side and I can't figure it out. What are we going to do here? Well, we're okay. We can actually say the whole side. So we can actually say 4 is to 24. The little side is to the whole side as, no, I can't do that. Man, I'm having some issues. Let's try again. Sometimes you got to try a couple different things here. That's why I'm showing this example. How about this? I know this side and this side are a partner, and I know the big side. So I can say 20 is to 24 as what? X plus 16 is to 30. Excellent. So that is the correct way to set that proportion up. Let's solve it just to make sure we have it. So I'm going to say 20 times 30 is 600. Just be careful with your distribution here. If you can distribute, you're in business. So we're looking at 600 equals 24x. I don't know what that is off the top. Whoa, that's not the calculator. What is that? Do I have a calculator? So 24 times 16 is 384. And then now just a matter of solve this. Subtract 384 from both sides, and we're looking at, what is that, 216? And does that work out evenly? How many times does x go in there? So how many times does 24 go into 216? If I divide them, 216 divided by 24, I believe, is 9. So we got x equals 9. Excellent. Very good. Moving on. Let's take a look at this. And this is the whole thing. This is kind of like the perspective drawing. I've got these parallel lines. Parallel, parallel, parallel. So if 3 parallel lines intersect 2 transversals, then the intercepted segments are proportional. So the same idea. It's not in a triangle now, though. It's just saying that, okay, boom, what matches this, just like this matches this. So really I can say, oh yeah, GM to MT is the same thing as OA is to AH. And again, there's more to that. You can do the big sides and whatnot, but that's the general idea. This is to this as that is to that. I love it. Very good. All right, so let's try this one here and see what we come up with. We're looking at, I've got my parallel lines here, and can I fill in some, if this is 6, this is 4, so this is 2. So sometimes you got to fill in the information here. Now can we set up a proportion? Sure. I know 4 is to 2 as what? 8 is to x. Awesome. You know, there are other ways to do this. It works out the same way, and we can try it if you want. I was just trying to give you one way to do it, but you could also even say 4 is to 8 as what? 2 is to x. I don't care which way you do it. I was trying to be consistent just so I didn't mess anybody up, but you get the same answer. Let's check it out. If I cross multiply, I get 4x equals 16. So x, when you divide them, has got to be 4. So you're going to the same thing here. When you cross multiply, what do you get? 4x equals 16, x equals 4. So they're both the same thing. I was just going this side is to this side as this side is to this side. And again, you can do totals. You can add them together and do the big side as well. All proportional. So pretty cool. How about the next one? The next one, I don't know this little chunk, and I can't really find it because of this, so I'm going to have to use something. So I'm going to say 20 is to the whole thing. So 20 is to the big 4x minus 8 as what? 15 is to the whole thing, which what is 6 plus 15? 21. So I'm going to say as 15 is to 21. Awesome. So can we cross multiply and solve this? Sure. 21 times 20, what is that? I think that's 420. If I multiply this way and then multiply this way, I'm looking at 15 times 4x minus 8. Let's do a little distribution. So solving equations, which I think you guys are getting really, really, really good at. What is this? This is 60x minus 80, 120, is that right? And then I'm going to add 120 to both sides to get x by itself. So we're looking at, what is this? 540 equals 60x. So divide both sides by 60. What do we end up with? We should end up with 9. Fantastic. That is it. That is the last section of the semester. Good work. I hope the master check goes well. I'm going to end you with some 3D perspective drawing on street art. Pretty wild, pretty cool stuff coming out of the sidewalk. All right. Good luck. Peace out.
you to won't trip me. My trip, my trip, my trip,